One of the things that we'll do later in the year is some units will get their own focus on different states of matter. Like there's a unit in the second semester where we just look at a whole bunch of different laws that go with gases. And there's another unit where we really just focus on liquids. So that's later on. We're going to get real deep and dirty on all of the different facts and studies and laws of these different states of matter. Today, I just want to introduce them to you. This shouldn't be mind-blowing in regards to some of the vocab, because a lot of this is like 6th grade vocab, so that's good. The more 6th grade vocab I can give you, the better off you'll be for your first test. So let's take a look on our cheat sheet. We're going to just look at the difference between solids, liquids, and gases. The biggest thing I want you to be able to know between the solid, liquid, and gas state, and when I say that, really what you should imagine is a block of ice, all right, liquid water, and then the gas vapor that you would get if you were to boil water, all right? Now this is just the water example of a solid, a liquid, and a gas. This can be applied to a bunch of different substances, but water is a really good one to think about because you're so familiar with it that you can associate what I'm talking about very easily. If I want to take a much closer look at these different states of matter, though, and look at the molecules that make them up, then here's what you would see from one to another. The solid form. All right, like a solid, like this eraser here is solid. If we were to look at the molecules as up close as we could, they would be jammed very tightly together. Solids are very tightly jammed, but the molecules that make them up are vibrating. Can't see it, but they're always moving. All molecules that make up matter are in constant motion. Liquids, on the other hand, have slightly looser packed molecules to the point where instead of being so tight together, they can kind of flow over one another. And then gases are the ones that have molecules that are the furthest apart, because that substance that you're used to for my solids and my liquids, you know, kind of dissipates. And then the gases are the particles that fill the air. How do you get from one to another? How do you get from one phase to another? How do I make my ice become water? Okay, melting, it's a good keyword, but really physically, what do you do to ice to make it turn into water? Yeah, you're trying to be too chemical on me. What would my daughter say I need to do to the ice to melt it? Add heat. Add heat, right? But I appreciate y'all trying to really jump ahead. Yeah, you need to add heat to go from ice to water. How do you make water turn into a gas, turn into vapor? You add more heat. By adding heat, you make the particles move faster. If I go back to my solid example where they're really, really close together and vibrating, when you add heat, they start to vibrate faster and faster and faster. And as that ice cube is receiving more heat, eventually the molecules start vibrating and start rolling. And that's where we've entered the liquid state. But then, if you add heat to the liquid state, well, then that will start to move faster and faster and faster. All right, it's the reason why when you boil water, you can see the water start moving as you add the heat, until eventually the particles move so far apart that they enter another brand new phase, the gas phase. So the difference from one of these phases to another, solid, liquid, gas, is the amount of energy, heat, that is available which dictates how fast the particles are moving. Of course, to go the other direction, what would you need to do to make a vapor become water? How do I make the gas turn into water on leaves in the morning? What are we doing? Taking away the heat. It just goes the other direction. And we'll talk more about what those processes are called in just a few minutes. A couple other things about solids, liquids, and gases in regards to their setup. Solids are said to have a definite shape and a definite volume. When I say that a given solid like this eraser has a definite shape, that means that it's not going to change shape very easily. If I take this eraser and I try to get it into this beaker, it won't do it. All right, I would have to destroy this solid to make it change shape. Solids don't really want to change shape very easily. They also have a set volume, meaning that this eraser takes up this amount of space, and if I throw it over there, it's taking up the exact same amount of space over there. The volume doesn't change. Liquids are slightly different. Liquids, got a liquid sample here. Liquids don't have a definite shape. Right now, this liquid's taking this bulbous, fat shape. But what I can do is ask it very nicely to change into a different shape. And now, instead of being fat and bulbous, it's tall and skinny. The eraser wouldn't do that, but liquids will let you change their shape. However, they don't change volume either. Remember, volume's the amount of space that it takes up. Right now, this is 250 milliliters of liquid, and even if I pour it back into its original container, it's still taking up, whoops, unless I spill it on my hands, it's still taking up 250 milliliters, the same volume. So far, solids always have the same shape, always take up the same amount of space. Liquids can have a different shape, but always take up the same space. What about gases? What about gases? What gas is the most abundant gas in this room? Who knows? Try again. Not carbon either. Most abundant gas in this classroom is still not oxygen. Well, now you know a Jeopardy question, right? Nitrogen. There's more nitrogen in here than anything. Anyhow, that's not important. Gases will let you change their shape and their volume. If we imagine that this room was closed off and all the gases that were in here, there's a lot of oxygen and other stuff in here too, obviously. We're breathing nicely. But if we were to change the shape of this room, for example, if we were to start closing the walls in, well, the room would get smaller, and the gases would happily let you do that. Pressure would rise, but gases will let you change their volume, and they'll let you change their shape. We could even kind of twist the room into a different shape, and the gases would say, okay, and let you do that as well. Now, we could actually close the walls in all the way tight in this room to probably about a box this size. All right, the box would have a lot of pressure built up in it because we pushed it together. But all of the solids in the room, they would all be breaking and busting because they don't want to change shape and volume the way that the gas will. So one more time to summarize, because it's good for your brain to keep hearing it. Solids always have a constant shape and a constant volume. Liquids always have a constant volume, but they'll let you change their shape. And gases have constant nothing. They'll let you change anything about them that you asked to change. Any questions so far? Flip to the back of your cheat sheet. We've got some real simple vocab that I want you to know on the actual process of changing from one of these states of matter phases to another. And some of them you're already very, very good at. If I take my ice cube out of the freezer and it turns into water, we say that the ice melted. This is melting. If I put water into the freezer, we say that that water froze. Yeah, this process really is scientifically called freezing. So those are definitely the two easiest. What about when we spill water on the ground and that water eventually disappears because it turned into vapor in the room? We call that process evaporation. We can also call it vaporization. That's a more big boy word for it. Or you can even just refer to it as boiling. You can see all three of those as acceptable words to describe that process. And what about in the morning where the air cools off and on windows and stuff becomes liquid once again? What do we call that? Condensation. A gas turning into a liquid is condensation. Now, there is a new word that I'd like you to know. And it's where there's a state of matter skipped. If a solid directly becomes a gas, meaning that the solid never gets wet before turning into a gas, we call this sublimation. Can anybody think of an example of something that they have seen sublimated? A solid that goes directly to a gas without getting wet. Dry ice. Dry ice is the most common example of sublimation. All right, it's that solid carbon dioxide that is a block that just drifts off into what looks like smoke.